Hi guys!
Do you guys want to buy something?
It's a brand new mineral water called Donut Water. It contains a high quality natural ingredient.
Sure, I'll buy one. What about you?
No, I'll pass.
Tomorrow. Day 3. 1 week later.
It must be the water. How can the water have anything to do with it? She said the water was exotic. So, it may contain high concentration of chlorine. But how do we know though? Let me use gravimetric analysis. What is that? Here.
Gravimetric analysis is an analytical technique in which the analyte or the substance being measured. It is selectively converted into an insoluble form, usually a precipitate. The precipitate is then isolated, dry, and weighed. Next, we are going to talk about the uses of gravimetric analysis. First, environmental monitoring. It is commonly used for detecting heavy metal in soil or water. It is also for assessing overall water quality. Second, industrial process control. In industries, gravimetric methods help monitor chemical reaction and ensure the quality of product by meeting required chemical standards. Lastly, food and pharmaceutical analysis. It is used to determine the nutritional content in food products and ensure the correct composition in pharmaceutical. Next, the advantages of gravimetric analysis. There are many reasons why gravimetric analysis is still relevant today. First, it is highly accurate and precise because it is based on direct mass measurement. Second, possible error during the procedure can usually be identified and corrected too. Next, there's no need for instrument calibration aside from using an accurate balance. After that, it is relatively inexpensive as it doesn't require high technology instrument. Lastly, it can be applied to macro sample, which means it is useful for analyzing larger quantities. Next, disadvantages of gravimetric analysis. Despite its strength, gravimetric analysis does have a few limitations. First, it often requires long experimental hours, especially during filtering and drying. Second, it can only provide results for a single element or a group at a time. Lastly, the method depends solely on the measurement of mass.
So let's dive in deeper. There's 4 types of gravimetric analysis, but I'm only going to explain 2 of them to you guys, which is precipitation gravimetric and also volatilization gravimetric. Precipitation gravimetric is a method where analyte is converted to insoluble precipitates that is filtered, washed free of impurities, and converts to product of known composition by suitable heats, treatment, and then weighed. Volatilization gravimetrics. It is a method that uses thermal or chemical energy to separate substances in order to measure their masses. In this video, the type of gravimetric analysis that we are going to use is precipitation gravimetric. How does precipitation gravimetric work? Let me break down the method to you. Firstly, dissolve the sample using a distilled water and filter if there's an insoluble part to avoid contamination. Second, reagent is added to form precipitate so that once it's dried, you can weigh its mass. Third, filter the mixture using filter funnel and also filter paper and then dry it and at last weighed it to get the precipitate mass. Oh, now I know. But there's a principle that you need to follow to measure the precipitate mass. Oh, what is it? First, quantitative precipitation. The dissolved sample mixed with reagent will have a reaction that needs to complete the reaction to form a precipitation to ensure accuracy. Second, complete drying. The precipitates must be dried whether in oven or furnace until it reaches the constant mass. Any water or solution present will cause an error while measuring the mass. Third, precise weighing. Use an accurate weighing like analytical balance to get the precise mass of the precipitates. And lastly, experimental control. Temperature, pH, and time must be controlled to make sure the reaction is complete and to avoid contamination.
Into the methodology. Now, let's look at the apparatus used in this experiment. We have a beaker and a conical flask to put or hold the solution, a filter funnel and a paper to filter the precipitate, a glass rod to stir the solution, a porcelain dish to put the paper and precipitate, a volumetric cylinder to accurately measure the solution, an analytical balance to accurately weight the mass. Chemicals. In this experiment, we will use nitric acid and diluted nitric acid, a water sample, a distilled water, and silver nitrate in a solid form. Now, let's look at the procedure. Preparing the solution of water sample. First of all, measure the sample water exactly 100 ml and pour it into 250 ml beaker. Then, add 2 ml of nitric acid into the beaker containing the water sample. It is important to prevent the precipitation of other products such as silver carbonate and silver hydroxide. Move on to the preparation of silver nitrate. Weigh accurately 10.8 mg of silver nitrate and transfer it into 250 ml beaker. Then, add 10 ml of distilled water into the beaker. Then, by using a glass rod, stir the mixture until all silver nitrate has been dissolved. Precipitation. Firstly, add silver nitrate solution to the water sample solution while stir it slowly. Then, let the mixture set for about 10 minutes. Optional, you can heat the mixture by using Bunsen burner. Filtration. First of all, set up the filtration apparatus. Don't forget to fold the filter paper using a correct technique. This allows the liquid to flow smoothly and prevent the loss of precipitate. Moreover, don't forget to wet the filter paper with distilled water to ensure it sticks properly to the filter funnel's wall. You can filter the solution by pouring it through the filter funnel. Washing. First of all, rinse the beaker with 3 portions of 10 ml of cold distilled water. Then, rinse it again with 2 portions of 5 ml of diluted nitric acid. Drying. First of all, make sure there's no water left in the filter funnel. Then, take out the filter paper containing the precipitate and place it into the porcelain dish. Then, place the porcelain dish into the oven at 130 Celsius for 24 hours. Now, the precipitate of silver chloride is ready to weigh using analytical balance. Here are some of the precautions. Make sure to dissolve silver nitrate properly for more accurate result. Let the mixture of silver nitrate and water sample for complete precipitation. Wear safety goggle and hand gloves while handling silver nitrate and nitric acid. Gravimetric factor, we were able to determine the amount of chlorine in the water sample. Mole of analyte and precipitate was obtained from the stoichiometry chemical equation. Based on the data collected, the calculation was done as shown. In conclusion, we were able to obtain silver chloride precipitate, and from there, we were able to determine the mass of chlorine in the water. Comparing the advised amount of consumption of chlorine from WHO, which was 5 mg per day, the water sample indeed has a high amount of chlorine, which was 9 mg per 100 ml.
Now that I know all the weaknesses, I can now mass produce this product.